Pulumi mostly focuses on providing building blocks that we can use to create cloud infrastructure, but because they represent real-world cloud components, they are also fairly low-level abstractions. Because of this, it can be quite verbose and, quite frankly, annoying having to explicitly set up every subnet and every route table when you want to create a simple network. That's when component resources come into play. So Pulumi provides two kinds of resources, a custom and component resource. A custom resource is one that directly maps to a specific type of service component in a cloud or service provider. It corresponds to the resources you'd provision using providers' APIs, management consoles, or a CLI. And a custom resource is no different, as it too needs to have the CRUD lifecycle methods implemented. On the other hand, component resources are a higher level abstraction, which encapsulates one or more custom resources, and this is what we're going to focus on today. They are useful for creating reusable and shareable abstractions. For example, you might create a network component that includes a VPC, subnets, security groups, routing tables, NAT gateways. You could even have a single component for deploying multi-cloud to both Azure and AWS at once. Comparing this to CDK, it would fall somewhere in the realm of an L3 construct, like an application load balanced Fargate service, for instance. In this video, I'm going to create a Node.js function component for, well, you guessed it, deploying lambdas written in Node.js. Every lambda needs to have a runtime and architecture defined, an execution role, some basic permissions for interacting with CloudWatch, and maybe some custom permissions as well. In short, it's a lot of boilerplate, and I want to take some load off. Let's check out the project files. This is a Pulumi project turned monorepo using pnpm, and the component code will be in the Node.js function package. To create a component resource, we have to extend the component resource class and call its constructor. Here we need to provide four things: a unique identifier, a resource name, some props, and resource options. The pattern for the Pulumi ID is package module resource. This is the same pattern you'll see when provisioning resources or looking them up in the Pulumi cloud. This is to ensure uniqueness to avoid naming collisions with other providers, clarity about what kind of resources are being created, and it creates a namespace for your organization. Let's start by creating a role with a trust policy for a lambda, meaning only a lambda function will be able to assume this role. All other permissions will be assigned to it. I'm also going to pass a third argument and set parent this. This is to bind the resources to the component and have them inherit the resource options that were passed, so if, let's say, user specifies a different provider, all resources that are a part of the component will also use it. This also ties the child's lifecycle to the parents and makes it easier to see why and where a resource was created. Moving on, we can actually create the Lambda resource now. I'm going to provide some useful defaults and use the roles ARN. Again, I'm setting the parent option, which I'm going to do for every resource. Every Lambda will try to send logs to CloudWatch, so I want to set up the role with some basic permissions for that, but users will also want to assign permissions, so I'm going to create a method and kill two birds with one stone. I'm overloading the signature here to allow either an existing policy's ARN or a new policy object. If it's a string, we're just going to assume it's an ARN, otherwise we're going to create the policy, and then either way we're creating a role policy attachment to attach it to the role. I'm going to go back to the constructor and use it to add an AWS managed policy, which basically allows the Lambda to stream logs to CloudWatch. There's one more very common scenario for Lambdas that I want to handle, which is to add a resource-based policy to allow another service to invoke the Lambda. This will be a method on the component instance, and it will accept a principal and optionally an ARN. The action is Lambda invoke function. We need our function's ARN, then use the principal and set the source ARN as well. Okay, so that's it for the implementation, and we can demo it. I've already prepared it, so let's quickly go over the code. First, I'm creating a zip from the functions directory using the asset utility from Pulumi. The file name is hello world and the export is handler. I'm using the grant invoke helper to allow access from an API gateway. I want to keep this brief, so I'm not going to create and integrate these two, so it's without an ARN. But what this does is it says that a service from this principal can perform this action on this function. If I had an ARN, then it would restrict it even further to an API gateway with this particular ARN, because without it, this function is, for all intents and purposes, a public lambda. Last but not least, I'm adding another policy, this time for adding items to a DynamoDB table. Let's provision and see if it works. As you can see, all these resources are created as part of the main hello world component. We can see that identifier, so I can tell this is my own custom component, and it has several AWS components in it. If I go to the Pulumi cloud, I can see it there too, either as a list or a graph, which is a nice touch. Let's go check out the Lambda. Okay, the code checks out, no permissions. Here you can see that resource-based policy for an API gateway, the CloudWatch permissions from the managed policy, and my own DynamoDB permissions too. So to sum up, in Pulumi, resources are the core elements representing cloud infrastructure components like databases, storage, and virtual machines. They are managed by Pulumi's resource providers, which interact with cloud APIs. Component resources are higher-level abstractions that group multiple custom resources into logical units, making them reusable and easier to manage. For example, a network component could include a VPC, some subnets, security groups, NAT gateways, and many other network components. These are similar to L2 and L3 constructs in AWS CDK, which often include very good defaults for easier configuration and provision multiple resources. That's it for this video. Thanks for watching.